Hello everyone and welcome. In this video we are talking about what is possibly the fastest shifting transmission out there, Koenigsegg's light speed transmission. And we're going to get all into how this transmission actually works. Now this video is brought to you by Autotempest.com. I'll get more into that later on in the video, but as many of you may know, I'm going to be replacing my Honda S2000 with something different, so I've been using Autotempest quite a bit lately as it's an awesome website to look for used cars. So the light speed transmission is used in the Koenigsegg Jesko. It is a 9 forward speed transmission. There are 7 clutches, 8 if you count the clutch for the differential. This car is producing 1600 horsepower on E85. And so I've got drawn the light speed transmission here. This is a simplified diagram in order to understand how it works. It's not the exact layout of how the gears and everything look. And then here on the left, we have a simplified dual clutch transmission with just 4 speeds. And the reason why I drew this is to help illustrate some of the advantages that this light speed transmission has. So first, let's do a little walkthrough here with this transmission and make sense of it all. So we have our engine, 5-liter V8 twin turbo. It is sending that power directly to the input shaft of our transmission. So this is all fixed together. There's not actually a flywheel. All of these gears will kind of rotate with the engine, and that is going to be essentially the flywheel. Now everything drawn here in black is all fixed, so all of this is rotating together. The colored gears are on bearings. So this is on a bearing, these 3 right here are on a bearing, and these 3 right here are on bearings. And so how this all works is you've got 3 shafts, and then on these shafts you have separate gear pairs. So you have compound gears here rather than like in a dual clutch transmission. In this case, how it's drawn, you just have 2 shafts and then you have each gear pair on those 2 shafts. So here we're sending power first from the engine to this shaft right here. It then has the choice between any of these 3 gears. Now each one of these 3 gears has a clutch pack connected to it. So how this works, you've got your clutch pack with the gear, it's paired with that gear, and then the shaft itself can be disconnected or connected with that gear using that clutch. So if you close this clutch pack in red right here, clutch pack number 1, that will pair these 2 gears together and that will force this shaft to rotate this shaft. Now at the end of this shaft, we have 3 additional fixed gears, just like this first shaft has. So for example, let's say we lock up this first clutch pack. These 2 here are completely open. So power is going to come from the engine to this first gear right here and then over to these 3 gears and then rotate these 3 gears. Now these 3 gears right here, once again, each have their own individual clutch pack. So they're all rotating individually and you can choose which one you want to send power through. So in order to send power to the rear wheels, ultimately with any gear, you're going to have to close 2 clutches in the case of forward gears. So let's just walk through the example first gear. So for first gear, we're going to send that power over to this first little gear right here. We've got that aggressive gear ratio. We close up this clutch pack right here. These are open. We then close up clutch pack number 4. And so then we have an aggressive gear ratio, another aggressive gear ratio, and that's our most aggressive gear ratio that we could possibly have. Send that to the rear. So we're just closing packs 1 and 4. Every other clutch pack here will be open. So power is going to come across from 1 down to 4 and then to the rear wheels. For gear number 2, we open this and we close this, and that's all that's required for the gear shift. You open one clutch pack, you close another clutch pack. So power comes across from 1 down to 4, instead now down to 5. If you want third gear, you do 1 and now 6. And so you can do that for each gear pair. So you've got 9 total speeds using 6 gear sets. So let's say we want to then shift from 3rd to 4th. Well, we're going to open up 1 and 6, and then we're going to close 2 and 4. So now we're going power to here, and then power to here, and then if we want to go to 5th or 6th gear, instead of going to 4, we go over to 5, we go over to 6. And then for gears 7, 8, and 9, same thing. You open up this one is also open. Power comes across over to the 3rd clutch right here, and then to 1, to 2, to 3. So that's 6, 7, 8. So this will be gears 1, 2, and 3, 4, 5, and 6, 7, 8, 9, depending on which one of these gears you have selected here on this secondary shaft. And then for reverse gear, as you can see, power is going to come across, it's going to switch directions, and then it's going to switch back to the original rotation of that first shaft if you go through this compound gear. Now, if you just go straight across, you will change the direction. So for reverse, you open up all these clutches and you close clutch number 7. That reverses the output shaft's direction, and you drive backwards. Wonderful. And then just a very quick example of shifting, because you can shift from any one gear to any other gear extremely quickly. So we're going to go from 9th to 2nd just to demonstrate that. So 9th gear, we're in 3 and 6. These are both closed, everything else is open. We want to go to 2nd gear, which is 1 and 5. So we open up 3 and 6, and then we immediately close 1 and 5, and that puts us in 2nd gear. So you're switching 2 clutches on, 2 clutches off simultaneously, and you make that gear change happen. Extremely, extremely fast. So how does this compare to a dual clutch transmission? So here we have a simplified 4-speed. Generally speaking, they're going to have more than 4 speeds, but we're just using this to better understand how it works. So we've got 2 separate shafts. On one shaft, you have gears 1 and 3. On the second shaft, with the second clutch, you have gears 2 and 4. Now I've just drawn single clutches here to simplify it. Generally speaking, in a dual clutch, these are going to be wet multi-plate clutches, and same with all of these clutches. These are all going to be wet multi-plate clutches. So, that's just a durability thing, makes them last quite a long time if they're bathed in oil, and there's multiple discs. So here, let's say we're in 1st gear. Well, this blue clutch is going to be engaged, and we're going to be sending power from here to here. We have a selector, so this collar will engage this 1st gear using the selector fork, and we'll send that power from here over to the rear differential. So this gear is on a bearing on this secondary shaft, and this collar rotates with the secondary shaft. So they'll mesh together and force power to come across and then to the next gear. Now let's say we want a really fast shift to 2nd gear. So what we can do, because this second clutch is open and not engaged, we can actually mesh this gear right here and pre-select it using this shifter fork. So this shifter fork will force 2nd gear to already be engaged. So 1st is engaged and the clutch is engaged, so we're sending power this way. This is not engaged, this secondary clutch right here, but we've already selected the next gear. So all that needs to happen in order for the gear shift to occur is you open that 1st clutch and you close the 2nd. So it's an extremely fast transaction because all you're doing is switching which clutch is engaged. And so you'll immediately shift power from that 1st gear directly over to that 2nd gear. So you have an extremely fast shift and you don't have a total loss of torque while you're doing it. Very cool advantage of dual clutch transmissions. Now on a track, this is wonderful. You're never really going to run into many cases where you have to shift multiple times down or multiple times up. It's fine to go through each gear individually. On a road, however, that's a much more common occurrence. If you floor it on the highway, things like that. And it also may not guess on a road what the next gear is. So on a track, it sees you're flooring it, it knows you're going to upshift. On a road, it may not know what you're going to do next, so it may not know which gear to select. So let's say you're in 3rd gear, and you want to shift to 4th, well, it might have selected 2nd because you're on the brakes. Or let's say you're in 4th gear and you actually want to go down to 2nd gear because you're on the highway and you want to accelerate quickly. Well, obviously, because the same color is used for 2nd and 4th, it can't pre-select 2nd gear. So the gear shift is going to take significantly more time. Versus with the Koenigsegg Lightspeed transmission, all that's required for any gear shift is simply opening and closing clutches. So it's a completely different design as far as how they do it. And the major advantage here is that, not only do you have all of that speed when you're on a track, but when you're on a road, it doesn't have to do any predicting. And if you're on the highway, it can shift down quite a bit. So you could say it's very good on both road and track. Did someone say road and track? Well, it just so happens that if you take the June issue and turn to page 16, you will find an article that I wrote on the Koenigsegg Jesko transmission. How cool is that? So Koenigsegg employs a technology they call U-Pod, Ultimate Power on Demand, with this transmission, and simply what that means is, so if you're using the gear selectors on the steering wheel or the hand selector in that center column, either way, there are 2 notches for that shifter. So if you're downshifting, let's say you're in 8th gear, and you pull it all the way back rather than just 1 notch will give you 1 downshift, 1 gear. All the way back puts you in the ideal gear for the maximum power. So if you're on the highway cruising, you want as much power as possible, you pull that gear lever back, that gear selector back all the way, and it puts you in the ideal gear based on what speed you're at, and then you just rock it off. So lightning quick shift, get in that power band of the engine, and then just fly. So a very cool little system they've incorporated. It also works with upshift. So if you want to go to the maximum forward gear, basically the most efficient gear at any time, you can do so very quickly with that double notch upshift. So a neat little technology they've incorporated to take advantage